speaker, Professor Vincent Larivière. He got his bachelor's degree and master's degree from University of Quebec at Montreal. And then he received his PhD from Information Studies at McGill University. After a short postdoc at Indiana University, he became associate professor at the University of Montreal Information Science in 2011, rose through the rank very quickly. He got the CRC on the transformation of scholarly communication in 2013, became associate professor in 2015, and became full professor in 2019. He's also a scientific director of, I don't know my French, Erudite Journal Platform, associate scientific director of the Observatoire de Sciences and de Technology, vice director of the strategic planning and communications, and regular member of the Centre interuniversitaire de recherche sur la science et la technologie. French. Okay, so today he's going to talk to us about equity for women in science. And before I sit down, let me remind you that as in any scientific discourse, all the discussions have to be respectful and also respectful for the speaker as well as the field itself. With that, I'll pass my baton to Vincent.
Thank you so much for the invitation. So yes, I did my thesis here more than a decade ago, finished in 2010, and it had been, I think, 13 years since I walked on campus today, and it actually felt really good. Felt some of the buildings needed love too, but you could say that when you walk on my university's campus also, it seems to be a common thing in Montreal. Okay, so the talk that I'm going to give today is based on a book that my colleague Cassidy and I finished, I would say, about a year ago, and that's going to be published in a couple of weeks from now. That has exactly that title. And it's a book that tries to basically provide a large-scale empirical analysis of the place of women, not only in physics, but actually in all disciplines, and trying to come up with some solutions to try to improve the situation. So my talk will probably last for about 40 minutes, and then we can have an open discussion on that. So yeah, so no, hopefully you won't fall asleep. Okay. So we're going to start by really looking at things empirically at a large scale. So we're going to show basically the lack of diversity from a gender point of view at the level of production. So who has the capacity or who's visible in research production? Are there any differences in collaboration practices between men and women? And then are there any differences, and at least in terms of perceived impact? And maybe a little caveat here, the method that we've developed does not allow us to look at any non-binary individual. So it's really looking at gender from a binary manner, men and women, and we can actually talk about the details if you want later. Then we're going to look at the division of labor in scientific teams, mostly focusing on a typology that has been developed about a decade ago, which allows us to, based on declaration, who has done what in a research project. Authorship gives an idea often in many fields of who has done the work. In physics, you guys are a bit peculiar where you sign in alphabetical order in some cases, but in most disciplines, the authorship order actually has a meaning. We're going to finally conclude with two aspects, which is to look at diversity of team and the type of research that is being conducted, and the diversity of teams and the research topics that are being studied. The last part will be mostly based on American data, for which we have actually in many ways better categories. So many people would tend to believe that the issue is solved. We know that from a diplomation point of view, women account for about half of the degrees for actually almost 3 decades. But when you look at the scientific community, they account about 1 researcher out of 3. So we are losing women at a rate that is higher than we are losing them. So that's a problem. Now let's look at the global picture. Why is that important? So of course, the first element that is often mentioned is that there's an ideal of social justice, that everyone should have the same chances, and so we should have some equal outcome for various participants. There's also an economic argument where basically there's a cost to a lack of equality, which is around $1.2 trillion. And of course, in French and English, trillions, I'm not sure they mean the same thing, but it's a lot of money anyway. Either language. countries that have higher equality also have much lower infant mortality. Now, the relationship there is probably more correlational than causal, but still, this is what we are seeing in the data. The fourth argument that is often heard is also that it's associated with a healthier democracy. And a fifth argument, which we will look at mostly at the end of the talk, is that it changes the type of science that is being performed. We can see science as something that is objective and independent of everyone's own interest and of that basically there's only one way of doing science irrespective of who we are, but it's not exactly true. What the data shows is that different social groups do science in a different manner with the same level of objectivity, but they focus on different topics, and that the fact that there's a lack of diversity of the research community also influences the science itself, and one could say in a relatively negative manner. So the World Economic Forum every year writes a big report, which is based on data on the places in society where we actually see gender differences. And I'm sorry, the quality of the projection is not so high, but basically every line here is a country. And what you have on the y-axis are four basically general categories. So the top one is the global gender gap index. Then you have the gender gap in terms of economic participation, in terms of educational attainment, in terms of health and survival, and then in terms of political empowerment. And we see that most countries, from an educational point of view, as well as health, don't have such a gender gap. Things are relatively well, but we'll see later that when you look at the subset of science, not just general education, the gap is quite substantial. So we are indeed losing work. From a political point of view, things are actually quite catastrophic. So the US is at about 30%, which means that basically there's 3 women for 7 men in the political sphere. Iceland is closer, but even then, there's a gap. There's actually no country where you actually have more women. And also from an economic point of view, the gap is also substantial. So in society in general, there is a gender gap, as you probably all know. Now, if we look at the scientific community, well, things are indeed closer to the political realm than to the educational realm. So you have a world map. I think you know that pretty well. Each and every country that is orange has more women in their scientific community. All of them. Yeah. There's not that much. Of course, things that are a bit lighter are closer to what one could say the parity zone. So Argentina, most Eastern European countries also are in the parity zone. Most of the Middle East and Asia is not, and North America, based in Europe, basically drive the average because this is based on the place of women in scholarly papers. Yes. You don't see it? Actually, Latvia is the only country where there's a tiny, I think at 51 or 52% more women. And we'll get to the reasons. Unfortunately, the countries that are above average, quite often, it's not for great reasons. Actually, I'll tell the Latvian example right now. Does anyone knows why there's more women in the science in Latvia? Because it's funny, but it's terrible. The life expectancy of men is 10 years younger. So men die. Basically, a woman's life expectancy is at something like 77. Men is at 67. So there's actually not only more women in science, but actually more women in the workforce in general, because men are being less. And what we're actually seeing, and I'll show a couple of correlations later, is that the biggest driver of that is actually proportion of women in the workforce and the gap in life expectancy. There's also another factor which plays a smaller role, is that scientific jobs are not highly valued in society. They're not well paid. And so if you're someone ambitious, you don't go in science. You go in politics, you go in the business sector rather than going into science. So yeah, so that figure is actually quite sobering. Now, if we just want to look at contrast a bit more, instead of having a middle point at the 50-50 balance, we put the middle point at basically the world average, which is 31%. That's the number that's been consistent in the last couple of years. Women represent 31% of authorships in science. And so Eastern Europe is higher than the average. South America, higher than the average, but the rest of the world is either on par or sizably lower. So, yeah. And interestingly, in Europe, the exception is German-speaking countries, so Switzerland, Austria, and Germany, which are actually the only ones that are below average. So we tried, once we had this data, we tried to find, are there factors that can explain that? Is there one thing that we could start to play with from a political point of view to actually improve things? So we used, so the United Nations has country level data for about 2,000 variables that span from being, Gini indexes. So is the economy more concentrated or is the society more equal or more unequal? What's the proportion of people with university degrees? What's the proportion of women in parliament? What's the GDP per capita? Is there something that allows us to explain little things? Actually, the parameter that was the highest, and that's R square of 0.25, which is actually quite low for your physical phenomena. You would probably not even publish that. In social sciences, 0.25 is actually, I would not say appropriate, but it means there's something in there because social phenomena are actually much tougher to predict than the physical ones. So the highest is actually, again, the life expectancy that I mentioned earlier. So there's not a single thing that explains that. This thing has many facets, and it's also a function of the disciplinary blend of the country. If a country focuses more on health sciences, it may actually have more women than if it focuses on physics.
There is no.
Yeah, go ahead.
There is no.
Well, these are population level data. So it's not a sample. Then there could be an experimental error, but it's typically not taken into.
So these are not genderized data. That is your Latvian example. That would be a single number for Latvia, the life expectancy, or two.
No, in that case, it's the male-female gap in life expectancy. It's the gap between the two, exactly. And so the larger the gap, and then you add it 10 years to 12 years, these are the countries that have the highest proportion of women. Then, of course, as I mentioned, there's disciplinary differences. Above, so health sciences, that's basically public health, has more women than men, at 55 to 60%. We see that in most disciplines, there's an improvement. Unfortunately, we don't have great historical data. So we start in 2008, and I'll make a small parenthesis here so that you know where this comes from. So this is based on the Web of Science database, which is a database that indexes scholarly papers. And we've developed algorithms to assign gender based on given names and surnames of people. It's not perfect, but it actually has a precision rate of about 95%. So there's names that are neutral, and those unfortunately have to be excluded. There's countries for which it works less than others. So for Russia, for instance, we're at about 99% precision because their family names are gendered as well as their given name. So it's actually quite strong. For India, it's more around 50% coverage. There's a lot of names for which we're unable to do that. And we've developed algorithms based on things that go from census data to basically Wikipedia lists for future parents who are trying to find a boy's name or girl name for their kids for each country. So anyways, it was quite fun, but it took a... Anyway, so we're able to assign that. And of course, there's a variation there. Yes?
So if women intentionally hid their gender with their publishing name, would you be able to pick that up?
No, we would not. So that's where I'm going with exactly that, is that prior to 2008, the database would not provide any given names. It was only the initials. So there's basically no signal. But in physics, again, you guys are peculiar. Quite often you don't sign given names. You only put the initials, and therefore the coverage. So the coverage is actually lower. Which is not your problem, it's my problem. But yeah, so that's kind of one of the limitations. But if you take health sciences, no one signs with their initials. It's really something that is not common. So we have blind spots in those analyses. But despite that, in the entire database, we're able to assign gender to about 80% of all authors. So there's a missing part, but again, it's actually quite sizable enough to be able to say something about what's happening. So, spectrum of discipline. I don't know if you know that discipline at the bottom. Yeah, that's physics. There's an increase. It's a relatively small increase, but it's only over 10 years. It's still happening. So basically, you've got mostly social sciences at the top, and physics, math, and engineering at the bottom, roughly hovering around 20%. So 20% of the authorship space is taken by women. So with our non-physicist mathematical skills, we made small projections for all of the disciplines, based, of course, on the slope that we had. And of course, there the error bar goes like that. I understand that. But the middle point puts physics at parity in around 2,200 or something like that. So don't hold your breath until then. Now, of course, different fields of physics have a different proportion of women. So in our database, there's about 8 subfields of physics. Lowest are at about 17% of ones, are at about 23%. So there's none that is close to parity. It remains within a relatively narrow margin. So basically, astrophysics and earth sciences is at the highest. And everything, let's say, CERN related, particle accelerator related. Yeah, you laugh. I have no reason. I don't understand why. You probably do, but is at the lowest. Keeping in mind, though, that these are the fields where the authorship list of 500 to 5,000 almost never have given names. So this is where we actually do have a stronger blind spot in the terms of the proportion of people we're able to assign a gender to. So gender gap at the world level, gender gap pretty much across disciplines, but even more important in physics. And now we've tried to look at, okay, what are the other places where we actually see those differences? And so we looked at collaboration practices and the collaboration network. Yes.
Sorry, for the gender gap part that just showed us before, and you also showed us geographically.
Yeah.
So I guess this is driven by the large average, which such as North America, as you call it, the large one. But if you look at places like Argentina, versus whatever, Mediterranean Europe versus US or Canada, is there a difference?
Yeah, I've removed that slide, so I can show it to you after if you're interested. But basically, it just shifts the window a bit. So let's say that you do the gender by country thing. Argentina is a bit higher by, let's say, 10% everywhere. But you see that the disciplinary variable remains the same pretty much everywhere, in the sense that physics would be their lowest, but their lowest would not be 20, it would be 30. So it's not the main driver. Okay, collaboration patterns. For every country, the collaboration network of women is more national, and the collaboration network of men is more international. For each of them, of course, one could say the difference is not huge. Well, it's 5 to 10% basically between the two, but it's consistent in every country. And of course, the proportion of international versus national varies by country. The United States collaborates much less internationally than Belgium, given its size. But we see this gap everywhere. Which brings me to the third element, which I think is quite a crucial one, about citations. So most studies have shown a gender gap in terms of citations received by papers led by women versus led by men of about 10%. And we tried with that analysis to see whether that was actually due to women not being able to publish with journals that were as good. So is that an effect of publication venues? So what you have in green is basically the men versus women difference in impact factor scores. And actually, I should have put only first author, it just simplified the figure. But what it shows is that there's a tiny gap in terms of impact factor between men and women, but it's actually quite tiny, and it's close to the mean as a function of the discipline, and it's actually quite small. But within those fields, their papers are less cited. So if we take physics, for instance, the gap in terms of impact factor scores, so that's again the score of the journal, which is an indicator one could say of the difficulty to publish in that journal, is about a 3% difference, which one could say is relatively small. But then in terms of citations received within those journals, it's a 10% difference, which again becomes quite sizable, especially over the course of a career, because this is paper-based. So when you sum them over every year, then it can lead to quite sizable differences in terms of impact. So that 10%, we've been trying to explain it with quite a lot of parameters. What we find, I have no slides on that, so you have to listen to me instead. So one of these reasons is actually self-citations. I'm not surprised, huh? So as a function of total citations, what is the proportion that are self-citations for men in blue and women in orange? Yeah, you're not surprised about that. But that alone does not explain everything. The main factor is actually homophily in citation. So men are more likely to cite their own work, but also to cite the work of other men. And also women are more likely to cite the work of it. So there's kind of a double penalty here, which again, once you add these 2 or 3 percentages of each of them, explains in a way the 10% gap in citations. I just want to go back to the previous slide because I think it's important. Instead of looking at things by discipline so that again, the men-women gap as a function of the impact factor, the difference in terms of citation rates is especially higher for journals that have higher impact factors. So again, there really is something happening where women are able to publish in a journal that are as difficult, but within those, there's a gap in the reception by the community. Now, division of labor. More and more scholarly journal, and again, I know that this is mostly something that is happening in the medical world, and I don't know how much physics journals have adopted those things, and I actually think very little. But more and more journals are actually asking authors to state their contributions. So yeah, the list of authors, and then who conceived and designed the experiments, who did the experiments, who analyzed the data, who contributed reagents, blah, 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 and who wrote the paper. So this was done by the Public Library of Science. Then a couple of years ago, they came up with a much more detailed typology, especially for something like wrote the paper. If I wrote 2 sentences, did I write a paper versus the person who actually wrote the paper from beginning to end, who actually wrote the first draft? So there's a typology that's called credit, and we actually have access to all of this data for a subset of journals, trying to see what did men do on papers and what did women do on papers. And the results are actually quite interesting. Okay, so that's the old typology: analysis, design, material, perform the experiment, and write. In blue, you have men. In orange, you have women. And the y-axis, the x-axis is academic age, because we know that the roles that people play change as they evolve, as they evolve in their career. So the more you're old, the more you're likely to write. The older you are, the less likely you are, especially in the medical field, to actually be in the lab and doing the experiment. But what's striking is that at every academic age, there's a huge gap in terms of who does the experiment. Women are sizably, by a factor of, 10 percentage point more likely to do experiments than men. And it remains constant. And the other way of looking at that is basically a woman who is at career age 15, that's the way we look at it, does as much experiment as a man who's career age 10. So she's a bit more junior, at least in the terms of the work that they're doing. So we actually wrote a paper on that, which is called On the Shoulder of Women, which was quite depressing to write, but again, shows that there's something happening there. And then in terms of writing the papers, we see that men are more likely to write papers. But then, when you look at the credit taxonomy, which distinguishes between writing the paper and editing the paper. So who writes the original draft? Well, actually, women are much more likely to do it. Who does review and editing? It's more likely to be men. So when you combine the two, men do it slightly more, but in reality, the heavy work of writing the paper is much more likely to be done by men. Investigation, which is the fourth from the top, is much more likely to be done by women. So you actually see a clear division of labor here, which even controlling for age, as we've seen in the previous slide, women are more likely to do the empirical work and men more likely to do the conceptual work. We also did a survey of authorship disputes. And that was based on around 10,000 scientists, which we've surveyed based on their study publications. So the beauty of this bibliometric data is that on most papers, we have email addresses, and we can go through ethics approval and then survey scientists based on some elements that we want to know. So women were actually more likely to be unhappy, let's say, with the way authorship was being attributed, and it was observed on every level, either in terms of naming, so who should be and who should not be an author, and as well as in terms of ordering, what should be the order of authors. Natural sciences, which is where you guys belong, was the one where the difference was the strongest, and where it was always significant from a statistical point of view. So, of course, I cannot not talk about the effect of COVID. So before going into the, let's say, the effect of the gender gap on the actual science that is being done, just another macro level too, and this is from my colleagues working at Northwestern University, where they did 2 surveys during the pandemic on how basically this situation was affecting scientists. And so basically, the next slide is actually quite clear on gender, but what this one shows is, of course, the change in terms of numbers of hours per week, and what sphere of research did it affect the most, or what field of what task from an academic point of view did it affect the most. So it mostly affected research, so less time for research, and slightly more times in terms of teaching, because we had to move to online teaching. Now, it did not affect all disciplines and all researchers in the same manner. So basically, women were actually much more likely to be affected negatively from a research point of view. They had less time because they had to focus on other tasks. So that's the first penalty. That's the direct penalty. The first hit of the pandemic was that women had less time than men to do research. And this was also observed from a journal submission point of view. So during the first 6 months of the pandemic, data shows that there's a strong decline in the proportion of manuscripts submitted by women. So first penalty. And the second penalty is what fields were most affected in terms of the time to do research. What do you see as the fields that were the less affected? Physics, economic, computer science, and math. What do these fields have in common? No proportion of women. At the top, biochemistry, biological science, education science, so all of the disciplines that are either heavy on wet labs or where you actually have to do field work, be it from a science point of view or a social science point of view. And these fields also have a higher proportion of women. So again, that was a strong effect. Okay, so how does diversity affect the type of research? So I'm going to present 2 analyses here. One of them focusing on medical research, which of course, hopefully you can make links to your own practice, and the other one focusing on the United States context. So in medicine, we've known that there's strong sex differences in the way the 2 sexes react to basically different types of drugs. And we know that there's actually differences here from a genetic, cellular, biochemical point of view. Literature shows that, especially in clinical trials, there's a lack of women. So most clinical trials that were made until the late 1990s were actually made on men, which has led to quite a lot of drugs on the markets that actually had adverse effects for women, but that were not documented because they were not part of these clinical trials. So what we try to do with this study is that how much do we actually see in the literature researchers taking sex differences into account? So you are doing a statistical analysis of this molecule. Do you actually break down the data for men versus women to see if there's different effects? And then the second element there is, does the composition of the team from a gender point of view make them more sensitive to take those things into account? So I'll go fast on the first part, because basically in green, you see that in all fields of health sciences, researchers are increasingly taking sex into account and making the statistical analysis differentiate by the sex. One reason for that is that the NIH in the US, so the research fund, the funder for health sciences, said it's now mandatory. So if we give you money, you actually have to do this type of analysis. So US researchers at least are doing it. I'll go fast on that because time flies. So more and more research in health sciences is taking that into account. Now, from a team composition point of view, teams that had a woman as either first or last, and especially teams that had women as first and last, so that were led by women, in all fields were actually more likely to take sex into account. So have a sensitivity in their statistical analysis to this component. So we do see with that, and again, this is based on a couple million papers for which we're able to know whether statistically others have done this sex-based analysis. So we clearly see that the fact that the team is more diverse does a different type of science and has a sensitivity to that issue. That brings me to the last empirical part, and after that we'll discuss, let's say, a couple of recommendations. So the effect of diversity and research topics. So again, this is really based on the US situation. There's analogous, there's an analogy that we can make with the Canadian situation, but keep in mind that it's really US based, which means that we are using here the statistical categories of the United States. So what we're adding here to gender is also the US concept of race, which is not a concept that we have in Canada. We would have visible minorities. So Statistics Canada has its own category. In the United States, there's basically 6 races. So Asian, Black, Latinx, white. You also have 2 races, as well as Native Americans. Native Americans and 2 races, the numbers were so low in the data, which is really telling in itself when we bring that to the Canadian context with our own Native population, that there's a huge problem there, but it was impossible for us to say anything meaningful other than, guys, they're not there, we need to do something about that. So we have the 4 most represented races, as well as men and women. And what we're trying to look at here is first, what is the place that is taken by these 8 social groups? And how does that affect the topics that are being studied in the United States? Here, for gender, we use the same method as I mentioned, which is that we're able to assign gender in a binary manner. For races, it's a bit more complex. So if you're curious, I'll point you to the paper, because we wrote a paper just to explain the method, because we are unable to assign it directly. Race is assigned probabilistically. So that name is 20% white and 70%, let's say, more likely to be associated with let's say, a black person. So the method is a bit more tricky, but it allows us, again, at the macro level, to see quite interesting trends, and I believe quite important. Okay, so what we're seeing here is that, and this is a zero-sum game. Where do we see? Where do we see less women? So underrepresentation is blue, and higher representation is actually in red. So less women here, and then more women, less men in L. But basically, there's a different representation of different social groups in various disciplines. But that's not the most telling figure. What we really try to focus here is the relationship between the authors' identities and the topics that they study. So we basically took all of the science and we did a cluster analysis to basically make scientific topics emerge. So African Americans, so Black Americans are actually much more likely to work on African American. White women are much more likely to work on nursing and education, and let's say much less on China. Latinx population work a lot on social disparity. So of course, this is looking at topics in social sciences. So those are topics that are actually, let's say, a social meaning. When you do the same thing for physics, you do see some relationship, but they're actually much less clear because the topic doesn't have the same relationship, let's say, with the social world. So that's for health sciences. For social sciences, it's even higher. So again, at the top right, you can totally see that the relationship between the topics as well as the proportion of Black people is actually quite strong. So there's, again, a strong effect, one could say, of who you are on the type of research that you're going to do, especially in fields like the social sciences, like the health sciences, that one could say are socially charged in a way. And so then what we did is that we said, let's do a little counterfactual analysis. For those of you who are not familiar with that, these types of analysis are, let's say, what if. And our what if is if the US scientific community had the same demographic composition as US population. So if there was no gap, if, let's say, it was a 50-50 split between men and women, and if, let's say, Black Americans, who account for 17% of the population, also accounted for 17% of the scientific community, what would we get more in terms of field or in terms of research, and what would we get less? I'm sorry to say there'd be less physics. There'd be less electrical engineering. There would be less of those fields, which are, again, where there's less women, and then there'd be more nursing. There would be more science that one could argue is directly socially related, and less of, let's say, more basic research, which in a way, I admit, can be a problem. In an ideal world, there would be more of everything. But the point here is that there's effects on disciplines. Now, when you look at specialties, and you may like that one more, I assume, there would be less economics when you look at the subtopics. So again, stock market, price, demand, firm strategy, etc., that decreases, and then much more on teachers, reading, minority, children, etc. So again, that I think gives quite a telling story. So to conclude and to give a bit of time for research, so the general conclusion is that we need everyone's input into science. The fact that there's barrier to entry to certain groups affects the type of research that is being done, and in many ways makes science less rigorous. We need teams that are diverse, where all of the perspectives are brought together. So at the end of the book, and we tried to, in our first instance of the book, we're like, okay, that's the situation, we're done. And then our editor said, okay, so your people are going to read the book and they won't know what to do. They will only know that things are going quite bad, and they'll be sad. So you need to come up with suggestions about what can we do. And the collective we encompasses many types of organizations. So what can we do as scientists individually? What can our institutions do as organizations? What can funders do with the different levers that they have? And so we came up, we gave this talk to many groups, trying to pick up everyone's brain. So what can we do? Well, we can go through, but this is really the point of discussion. What are the actions that we can make to improve the situation? So acknowledge the work of women scientists, provide training and mentoring for women scientists. The third one is actually quite crucial because there's other examples of that. Labs that have transparent criteria for authorship generally have a lower gender gap, or there's less problem. Also literature shows that when there's a clear agreement, there's less likely to be authorship disputes afterwards. And so these are things that we can implement in our own group. Avoid gender segregation in meeting. Use research indicator responsibly. So I don't know what is the McGill culture on doing bibliometrics and counting H indices and stuff like that. But given what we've seen and given the biases that are ingrained in those indicators, they actually reinforce the gender gap on many levels. So any evaluation that is more quant rather than qualitative, or one could say it's holistic, leads to a higher gender gap. Demonstrate zero tolerance for sexual harassment, which is of course, and embrace, and this is also quite crucial from a, one could say, childbearing point of view, embrace the diversity of research career. Starting a PhD later is not a problem. Leaving for maternity leave for 1 year or 2 years is not a problem either. Like, these are all things that we need to be able to see. The typical trajectory of finishing your PhD at 25, doing a postdoc for a couple of years and being a faculty at 30 is not the norm. It was the norm 50 years ago. It should not be the norm nowadays. So I mean, I'm going to stop here and we can look at others. So thanks for your time. I hope you're not too sad or angry. Happy to discuss.
Very informative talk. Let's go to discussions. Okay. Well,
Thanks for your talk. Your suggestions for authorship, what would you say in terms of the practice and physics of assigning it alphabetically? Would you say that that's a good thing or a bad thing in your view?
That's actually a very good question. I don't have a strong opinion on that because I see a lot of advantages to the authorship, and I see a lot of advantages to having non-alphabetical and non-given names there. But there's actually a good paper that looks at your community that was published about 2 decades ago, which tried to say, okay, these are high energy physicists, they're all blended in a group. We don't know who did what. And so it means that the capital and the hierarchy was created outside publications. And there was still a gender gap in the hierarchy that was created, who does the seminar, who talks the loudest, etc. So I don't think it solved anything. I like the idea, but by blending everyone in a group, I'd say it doesn't have necessarily a positive effect. But I wish more fields were doing that. I guess you do it out of necessity. And I make just a small parenthesis on this thing here, on contribution by discipline, because I have the same data for physics. And what we actually see in physics is that there's almost no difference because the way physicists assign contribution, they say, oh, everyone did everything. You don't care. And so everyone is at 100%. So they're good. So I must say, I like that a lot, but it doesn't mean that because we see no signal in the data that there's nothing underneath. And we see it with indeed a proportion of authorship. So yeah, I guess that's not a precise answer, but again, I think that's food for thought. There's advantages and disadvantages there. Yeah.
Okay. Adrian first and then Peter.
This is just a clarification while you have this slide up. Could you define what in this taxonomy was meant by investigation? Because to me, a lot of this stuff.
No, I agree. It's the empirical work. Who actually, so let's say in astrophysics, who spent time collecting the data, looking at the telescope or in lab work, because again, this is mostly medicine driven. Medicine has a strong emphasis on authorship because of the accountability problem and the crazy scientific frauds that they've been caught in. So basically you have 25 authors, you realize there's data, someone invented that. So who do we have in the data collection? Oh, it's Steve. Okay, Steve, where's the data? No, so that kind of explains it. So it applies differently, but it's who had their end in the work.
Okay. Peter,
Two questions. So you showed some interesting data that shows how diversity increases. Diversity as measured, we'll call it as race.
Increases
the diversity of research topics.
Yeah.
But then can't you correct you that in physics you did not find it always?
No, in physics, indeed. So physics, again, topics are not as socially embedded or socially charged. I apologize, I don't have the perfect word for that in English, but I think you get it. So there was a very low correlation.
So
Yeah.
had a bunch of other fields that had really low female participation. Is that true for those fields?
Yes, exactly.
So it's actually-
No, but that's a good point because it shows that minorities, at least in a US context, one of the things that they go for are things that's going to improve their own communities.
Mhm.
There's something I was talking with Abigail about that earlier, is the privilege of choice. Who has the choice to study whatever they want? Someone who has all of their other needs fulfilled. So as, let's say, a middle-class white man, as a kid, my parents would tell me, you can go study him. So I went and did social sciences. You went and did physics. But again, it's a privilege of being able to go and study what you want because you don't feel that you have a social responsibility to your group to improve their situation. So again, that explains, I think, quite a lot this trend.
Well, the second question, I didn't, are more like an explanation of.
Yeah.
Conclusion slide or suggestion what we can actually do to improve this in the.
Yeah.
What does that mean? Avoid cultural taxation and increasing representation.
Okay, so that means we have one woman in the physics department, okay? But we need to have representation of a woman on committees. Therefore, she sits on every committee. You see? So that's kind of a good idea that has an adverse effect. And there indeed the solution is simple. You hire more women.
So that means that you watch out for committee. I'm rich out of journals.
Yeah.
I just had a clarification question about the credit slide.
Yeah, sure.
Just sort of, when you say percent of authors.
Yeah.
Is that saying like say for the top, it's women are at like 60%. So is that saying like 60% of authors who are women?
Exactly. So it's percent of women of that gender. You are right. So basically, yeah, so on the top 70% of men who were authors contributed to the writing. Yeah. Yes.
At the same time, there was a graph that showed that there are more minorities participating in physics than like
Where did we see that? In that one?
yeah.
Okay. No, actually, it's so here the strongest. Okay, I'll be very frank. I don't like this figure because it's a zero-sum game across each of them. So you don't see what field have more of them or less of them. It's within that field. Each row is a zero. Each row is a zero-sum game basically. So women are more likely to be here. Are less likely to be here. More likely to be in L. Irrespective of their participation, let's say, or their them being Latin, Black, or white. So to go back to your question, so minorities are more likely to focus on things that can change their communities. And if we look at physics here, then that's what we're saying. Yeah, physics. One could say it's actually quite on the par, but again, it's the way this represent does not answer exactly that. Yeah. Yes.
There's a question from the YouTube chat.
Sure.
I'll read out.
Yeah.
So it says, there seems to be a lot of emphasis within institutions in addressing inequities using quotas. Can you comment on that?
Yeah, that's actually a very, well, I would say a common question. So quotas are a sensitive question because people say, oh, this person got hired not because of or their scientific quality, but more because of filling that quota. And I'm actually quite in favor of quota for a simple reason, is that historically we had quotas the other way around. The amount of men historically that have gotten their position because of their position in the scientific network was actually quite important. And so by doing that right now, we're actually recalibrating, and quotas are not a permanent policy. This is something to just bring back some equilibrium. And once there's actually equilibrium in the system, then position hopefully can be failed based on excellence, because we need to understand that the historical perception of excellence has bias that are embedded in it. So, and I know this position is not always appreciated by everyone, but I think it's important. The British Royal, not the British, the Dutch Royal Society, for I think 5 years only accepted women. They said now, like, we've had a deficit of women for a century. Now we need to improve things. And of course, it's not the best situation for those who are not part of those groups, but I think it's a necessary temporary policy to improve things.
There. I just was curious in your what if report. You showed that there would be less physics if the population and physics would correspond to.
Yeah, relatively less physics. Yeah.
Why? Why does the physics drop?
Oh well, but that's the data show. That's what the data shows. So basically, what this does is, if given that minorities are less likely to be active in physics now, if the scientific community was having the same proportion of different groups as the general population, that would be the field that would suffer. Because this is where, let's say, white men go. So it's an analysis that's called, again, as I said, counterfactual. So if the scientific community was equal in its population in terms of percentages as the US population, then that would be the field that would be less visible. I don't know how else to say it, but it changes, it gives a parameter to each discipline as a function of the participation of various races and genders. And so if that would be what would lower, and that would be what's higher.
Wait, there was a question.
Yeah.
Thank you. My question was about the COVID impact on research.
Yeah.
You said in certain fields you had more or less time that was lost.
Yeah.
That used to be dedicated to them. And so you mentioned something that one of the field that had the most lost time was like
biochemistry on top. Yeah.
And so you mentioned something about lab work, but were you able to say if it was because the researchers didn't have access to their lab anymore, or because they spent their time doing something else?
I think that the authors may have that in their data, but that's not things that were actually published. But I assume that this is mostly the reason why. I mean, here labs were closed or there were constraints on the labs. In some part of the world, it remained open. So I think there's a national component to that, to which we cannot get because the data becomes too sparse. But
Okay, because I don't know. I would so this is not gendered, right? It's just
no. On the left, it's only what fields were most affected by research time. But again, we know that those that were less affected are those in which men are more active.
Especially on that.
Yeah.
Going back in the fact that women's work was probably more effective than men's, since there's more likely women work. And then still the fact that children were out of school and women were probably the ones picking up the work at home.
That's the main cause. That's basically the main cause. And you may, I don't know how active you are on social media, but in the first couple of days, like when in March 2020, I remember I was teaching on the morning of Friday the 13th, March 2020, in the middle of my class. It was a big amphitheater with 120 students. And then they start chatting. Like half of the students didn't come because like things were, and then those who came, and then they start talking. What's happening? What's happening? Well, the government is closing everything. So well, let's end the class and go on. Anyways, so everyone was looking at social media all the time, and what you were seeing were men researchers saying, "Hey, it's amazing! Since I can work from home, I can finish all of the papers I wanted to finish. Like this is great! Yeah, pandemic." And then you had not that much, but I'm making character. And then you had my women colleagues writing, "It's a catastrophe. My young kid has the flu. They're all staying at home. I need to do the homework. Like, I don't know what to do anymore." And so you could clearly see the differential effect. And so this is an anecdote, but that's exactly what we see in the data also. So women who are more likely to have 0 to 5 years old, I mean, research time is minus 40%. There's no...
Another one from the chat. So what can physics learn from the health and biological sciences to achieve better equality?
Yeah, that's actually a good question. This is not an easy one because indeed the topics are different and the attractivity is different. So in a way, I think there's the image of the field kind of needs to change and be seen as something that is indeed more inclusive. But I must say I don't have any answer other than coming up with pure speculation on my part, and I don't like that. So I would say it's not an easy task. Yeah.
Okay, Ken.
So I have a question that builds on that a little bit.
Yeah.
In a very early slide, you distinguished yourself between opportunities and outcomes.
Yeah.
All of your data is about outcomes.
Yeah.
Do you believe that equal opportunities always lead to equal outcomes? And
Well,
the second part of the question
Yeah, that's a
is,
good question.
what can we do to change the opportunities in our field so that we can change the outcomes?
So I think a first step in giving equal opportunity indeed leads to better outcomes. The thing is that right now I don't think everyone has equal opportunity because of the way
Right,
the social
but my question is,
stratification exists. Yeah.
Believe that equal opportunities, gender-wise, will always lead to equal outcomes?
I don't think I can say always to that, but it would lead more likely to.
Because that's a critical,
Yeah.
that's a critical part of this.
I totally agree.
We could
Yeah.
have completely equal opportunities
Yeah.
and not.
And then exactly. So the argument that I often hear is that, and we see that with, let's say, talents in math. A big part of the story in physics is that women actually are more likely to be less interested into math at an early age. And they're kind of, so there's a K-12 story here, which kind of builds upon that. But there's then work to be done on that, which is it related to opportunity? Not really, but it's kind of changing the mindsets on many levels about what are boys good at and what are girls good at. And that could indeed help to achieve a more equitable outcomes for everyone.
Okay, so last question.
First, people decrease our male cap and.
Yeah.
These are they saying?
No, physics is not there, but and there's interesting data on that, is that physics, as I've seen and I've heard, as well as engineering, are field that actually had good increases in terms of women matriculation, and then it flattened. So at Université de Montréal, at École Polytechnique, post the terrible events that happened in the late 1980s, there was quite a huge increase of enrollment for women in engineering, and then it flattened for 20 years. As if it had reached some kind of artificial ceiling. But again, even if there's more women at the undergrad level, we lose them at the master's and PhD level. And the place where we lose them varies by field. We did the analysis in Montreal. We lose women between the bachelor's and the master's. In chemistry, we lose them between the master's and the PhD. In chemistry, so again, for different reasons, but there's something happening there that we need to work.
Okay, so let's thanks again.
Thank you.
We're going 1 and 2 in that direction.